Hello viewers, welcome to my channel Connect Civilians. So in this lecture we are going to see how to design a solar structure in SPREAD, okay, and also apply the wind load and dead load through the Excel sheet calculation. So this is our DWG drawing for the panels, and here the size of our panel is, the width is 1 meter and the length of the panel is 1.985, so it is written in mm. Okay, so this is our panel size and the panel weight is around 22.5 kilo. So generally this panel weight is mentioned by the client, or which through which we are purchasing the panel. You can get the weight from there also. Okay, so this will be our drawing, and here this is our framing in SPREAD. Okay, so we have already done the beam node connections in SPREAD, and here we have applied the section also. So I will show you step by step how it is done. Okay, this will be our column. So we are looking to the side view. So this will be our column, this will be your rafter, okay, and this will be your bracing, and here this this will be your sag rod. So sag rod is provided generally between the below the panels for the connection of the purlins. So this, if you see in the figure, this pink C channel with lip is your purlin. So on the purlin your panel will be placed, and it is tied by the rod. Okay, so nut bolt is provided, and it is followed by the IS codes only. So here we are going to see how to calculate the size of the different structure elements. So this will be geometry, and here we have also provided the transitional repeat, so that every property or geometry will be copied at a similar distance. Okay, so our length will be 2.06 between column to column. Here it is 3.06. So similar geometry we have taken here. So first we have taken the geometry. After that, after all the calculations and what size of purling and rafter is provided, here it is placed. Okay, so this will be your GA drawing. So, and this will be your purling. Okay, so geometry will be made and your sizes will be applied for the different structure elements. Okay, this is the column. So this column is provided a channel with lips, and from where we have taken, I will show you. Go to your section database. Okay, it is taking some time to load the file. Okay, go to cold form steel option, as in our solar panel structure we generally provide the cold form steel, and the code for this is IS801 and I802 also. Okay, you can go and check the code also. I will provide the link in the description. I'll also provide the code in our Telegram channel. You can follow our channel also. Okay, so this will be your cold form steel, and it is generally lightweight, so we have to take the cold form steel, and we have to go select the Indian codes. So this will be your channel with lip. So from here we have provided the uh, column size, and it is 90 by 50 by 2. So here we have provided 90 channel width is 90 by 50 by 2. So 90 will be your flange, web, and the flange will be 50, and 2 is the thickness. Okay, so you can also insert your own data if you want from the section database from the select menu. Okay, but now we are going with the 90 by 50 by 2. Okay, so from here we can select. So channel width lip look like this. So this will be your channel width lip. So 90 will be your the flange, the web, and the 50 will be your flange. Okay, and here it is 15, but in our Staad profile we have taken 2. Okay, so if it is not passed, then we can follow the same data that is given in AutoCAD file. Okay, but for now we are okay. We are going to follow 90 shades by 50 by 2. Similarly for rafter. Okay, so this will be your rafter. What we have provided 80 by 40 by 4. So in our drawing it is 80 by 40 by 15. Again we have data is 15, but here we are going with lesser value. So if it will not pass, then we can increase the size. Okay, and the purling size will be 90 by 40 by 3.15. So if you want to go with the simple channel, you can also go with the simple channel in case of purling, but for safety reasons and for accurate check we are going with channel with lip in cold form. Okay, so here we provided for the 90 by 40 by 3.15 for purling, and this will be your bracing. Now bracing is provided, I will show you from the section. So this will be bracing which will support your rafter and column, through column. Okay, so this size will be 50 by 40 by 2. 50 will be web, 40 will be flange, and 2 is the lip. So now this will be okay. Okay, so 50 by 40 by 2, it is okay. 2 is the thickness. So these all are the thickness, and this will be your flange and web. Okay, and this is our sag rod. How sag rod is shown in the figure, you can see here. So it is used for the connection of two purlins. Okay, yes, threaded sag rod will be provided between both the purlin. Okay, so now this will be okay. We have provided sag rod, and we have taken the from the simple structure from the section database. Okay, and we have provided the material property as steel. Now this will be okay. So we have provided all the components with properties, and these are some of the sizes. If this check will not pass, so we can increase the size according to these values. Okay, so I've already done the check. So I've already increased the size. As first we have taken the size as 35 cs 35 into 1.25, but it was not going to pass, so we have changed to 90 to 50 by 2. Okay, so this will be right now. This will be okay, and here if you see the 3D diagram, I will show you. This will be your figure. Okay, so this will be your column, and this will be your bracing, and this is the rafter, and this will be your uh, purling, and sag rod is connected between two purlins. Okay, here, and this will be your purling, and it will come above the rafter as shown here. And how we have done this, go to the specification and go to the beam and provide the offset at start global. Okay, and you have to move the purlin above what says you have provided for rafter. If you check the property, and we have provided the rafter size is 80 by 40 by 2, so our web will be 80. Okay, so you have to provide the 80 mm in Y, so it will go up. Okay, so we provided 80 mm in Y direction at start. Similarly at end we have provided 80 mm, and select this and assign to selected beam and assign. So at starting at end, first go for start, assign, and again go for end, assign. So select all the purlins together. Okay, and first go to start, assign, and again go to end, assign. So structure will be automatically come upside your rafter. Okay, now this will be okay. And if you want to rotate your uh, structure element, so we have rotated the column to 270 degree. How we have done, I will also show you that. This will be your size, and go to beta angle. So you have provided the angle to the column. So we have rotated the angle up to 270 degree. Okay, so why we have done that? Because your column will come perpendicular to the rafter here. So our column is, if you again rotate to 90 degree. Okay, yes, if you will see, the column is again rotated to 90 degree, so it is moved to another side. So we have changed from 90 to 0 degree. Just check, I'm showing you what is going to happen. Okay, assign, again go to 3D. So it will come like this, but you have to make it perpendicular to the your uh, rafter. So we have to move it to 270, so that your face of the open side will come in x direction. Okay, assign, you have assigned the property, and we have to check again the column. So this will be okay. Now again we have provided these values also. We have to go to load. You have to provide a dead load and the wind load also for the structure element. So how dead load is calculated? You have to assign the self weight as usual, how we have done. So go to dead load, go to add, after loading all the loads, go to self weight minus -1 in y direction, add and close. So it will come. Go to assign to view, and assign to all the structure. Again go to, and we have to also calculate the unit weight for the structure, for the load of the what we will say, the load of the your panel. Okay, so this blue color is showing you is your panel, and the size of the panel is 1.98 meter by 1.003 meter. Okay, so this will be your size of the one panel, and the weight is given as 22.5. so in this Excel sheet, okay, so this will be Excel sheet where you have to insert all the values for the calculation of dead load and wind load for solar structure. Okay, now in blue boxes you have to fill the data by yourself. Okay, according to the code, highest code 875 part 3, and after that your spreadsheet will automatically calculate all your forces in x as well as y direction, and also for the structure element. So here our module size will be 1.98, and the width will be 1.003. This will be okay. Weight of your module is 22.5 kg to insert, and your module weight per meter will be calculated as 0.1111 kilonewton per meter. Okay, and similarly here you have to insert this, and your module weight will be applied in downward direction, so you have to apply minus, so 0.111 in gy direction global y, and add it. Now this will be okay, and apply to all your purlin. So you have to apply all the loads in the on the purlin, add all the loads is coming at the top of the purlin only, okay, and it will, after that purlin will transfer the load to the rafter from the column to the ground, okay. So you have to select all your purlin and assign to selected beam, assign. So this load will be assigned. Similarly for wind load in plus y and minus y. So what is plus y? So wind load is applied to upward, from bottom to upward, that is plus y, and what is minus y? When wind load is applied from top to bottom in gravity direction, okay. So this will be your calculation here. So you have to fill some of the data here, what angle you have provided. So this will be your tilt angle, okay, this will be your tilt angle here. So here in this uh, frame start framing, we have done for angle only for 5 degree of angle only, okay. Here it is shown for 17 degree, but we have done for 5 degree as per given data. So here we have provided for 5 degree, and here we have that tilt angle is as 5 degree, okay, 5 degree is okay. So on the basis of this degree, so you have to find the your upward CP coefficient and downward CP coefficient, okay. So from clause number 7.3.3.3 will on from page IS code 875 part 3, you can get the wind load for the free roof, okay. So we have also get the data from the code for the easy understanding. So you can, so if you don't have the code, in emergency purpose you can just check the Excel sheet and get all the values, okay. So for 5 degree of angle and for solidity ratio as 0 degree, what will be your coefficient? For 5 degree it is 0.14, okay, 0.4, sorry. So we have provided the angle as 0.4 CP positive, and for negative what will be the value? CP negative will be for 5 degree, so maximum negative value will be taken. So it is for 0 degree, so it is ratio 0 degree, it is minus 0.7, okay. So it is minus 0.7, here it is taken. So CP negative and CP positive value is taken, and if you see the figure here, CP negative will be force applied from downward to upward, and CP positive will be force applied from upward to downward, okay. So you can get your coefficient from this table, or you can also check your IS code if you want, okay. So IS code 875 part 3 2015, you can also get the same sheet from clause 7.3.3.3, okay. So this data will be provided, and we have to insert all the data also. What type of structure is this, what will be the basic wind speed. So we have already done this in our previous wind calculation sheet for building structure. You can check from there also, you can understand how this value will be taken from the code, okay. And so we can go forward for all the calculations. So if you want to understand this, you can check that video also. I will provide the link at the end of the video, you can check, okay. So you can, it will take more time to understand all these values, okay. Now this will be okay. And what type of structure we have plotted, so it will come as type of structure will be 1, our basic wind speed is 42.3, our terrain category is category 2, risk coefficient will be 1, factor will be 2, 1, and topography factor will be 1, importance factor. So all the value in blue boxes you have to take from the code from IS code 875, okay. So I will provide the link at the end or in the description also, or you can also check from our Telegram group, okay. So this will be our tributary area of our panel, that is 1.93 into 0.99. okay, this will be our panel size, and our panel size will be different in this case. Okay, so here it is 1.98 into 1.003. This will be a width. So our tributary area is 1.98 and it will come between 0 and 10. So this value will be interpolated here from here, and your interpolation, after interpolation, your area averaging factor will come as 1. Okay, wind coefficient nationality factor will be 1 and combination factor will be 1. Okay, so these blue boxes you have to fill yourself. Again I will repeat, you can check my previous video, I will provide the link, so you can easily understand what is going in all the boxes here. Okay, now this value is calculated as design beam pressure as 1.074. so you have to use this value for the calculation of your STAAD forces. Okay, so for height 10 only we are going to see, as our solar structure height will not go more than these values. Okay, but for emergency purpose we have done for all the heights also, 15, 20, 30, 50. So what will the height of your solar structure is coming, you can take from that of the boxes. Okay, if the height of your structure is more than the 15, so you can check your design wind speed value, you can take the value as 1.18 in all the calculation. Okay, so here this will be okay. So our value will be taken, so you don't need to do anything, you have to just fill all these blue boxes and this value is calculated here. So your design wind pressure is coming as 1.074, and here if you see wind pressure, upward pressure on purling, so what pressure is coming on purling? Okay, from down to up, so you have to fill that. So this Fy, the force is in y direction, so your force will come as, for upward it is 0.7412. so this calculated value you have to fill in this positive y 0. So it is 0.7412. okay, so how it is applied I will again show you from the box. So go to add, go to member load, and here you have to fill. Okay, so add it applied in upward, so you have to not provide any minus sign. Again select this, select the all the purlins like this. All the load should be applied on purlin only, always remember. Select the load and assign to selected beam and assign, so this load will come. Okay, similarly for y direction, wind downward pressure on purling, so Fy for downward will be 0.424. so here you have to apply 0.424 as it is downward, so minus sign will be given, change close. Okay, so in similar procedure you have to apply the load on purlin only. Okay, so upward and downward pressure will be applied on purlin. And one more thing, here we have also done for forces from x direction. Okay, so our load is not much high, so we are not going to take that load for x and y direction. Okay, so if you want to take the load you can also take it. Okay, but as the load was not high, so I am going to ignore it, because we are going to apply the factor of safety as 1.2 or 1.5. okay, so that will cover the value. So with upward and downward pressure is applied on the panel. Now one more thing, we do also got the pressure on our structure element, the wind pressure on our structure element. Okay, so this will be a column, this will be our rafter. So some wind pressure is also applied from x direction or and from z direction also on the structure element only. Okay, so we are going to also apply that. Okay, but in heavy structure this value will be taken. For lower structure it is not considered as the value was not much high, so you can ignore, but for more great understanding, and so we are going to take the all the load from x and y direction on the structure element also. Okay, so here our clause number 7.4.3.2 b table 29. So on from ISO 875 part 3, so you can get this table, this table will be there. Okay, so if you want to check the code also, it is given on page number 41 here. Okay, all the different section will be provided, and how load is applied on the section it is shown here. Okay, and here our formula is also given for normal force and transfer force calculation. So what is transfer force? So it is generally basically perpendicular to your normal force. Okay, so this will be your Fn and this will be your Ft. The formula will be Cfn, coefficient for normal force, into Pd, design wind speed, into K will be your coefficient for uh, here it is given reduction factor. Okay, sorry, it is reduction factor. Now you have to go to code and K, and this will be your L. So most of the time most people is confused that it is written as upon or by, but it is L, that is the length of the member and the width of the member. Okay, always remember the formula, that is the length and the width. Okay, so we are going to calculate for per meter length, so we are going to consider 1 meter. Okay, so here for 0 degree and for 90 degree we are going to calculate, as we are applying from x direction for 0 degree and from z direction also. Okay, from 90 degree, so we have to calculate the value for both of the figures. So here will be your for 0 degree, so and this will be a 90 degree. Reduction factor we are going to consider as 1, at the length of the figure we are going to take as infinity. Okay, so after we have considered the channel section, column we have also considered channel, bracing also considered as channel, and the purging will be also considered as channel. So in any case, if you have not considered channel, you have taken the L section, you have to take the value of your coefficient for normal and the transfer force from these tables. Okay, so for C channel, here it is C channel, so we have taken the C channel, we believe it is generally similar to the C channel, so we have to take the coefficient value from this. Okay, if you have taken the L section and load is applied in this form. Okay, so load will be applied in this form, so value will be taken from here only. Okay, for 0 degree and 90 degree. So if you want to take the value from 45 degree also, if you want to provide the pressure from 45 degree, you can also take that, but it from 0 degree and 90 degree we are providing, and that will be enough for our structure. So for C, here we have to take the coefficient values for normal and transfer force, and our column is coefficient will be, we have to fill for 0 degree as in these boxes. So for normal, so all the structure element we have taken the C channel with leaf, so take the value for normal for 0 degree as coefficient for normal will be 2.05 and coefficient for transfer will be 0. Okay, so here we have to pick 2.05 and 0. Similarly for column we have to also put the same values. For bracing we have to put the same 2.05 and 0. In any case your section is L, so you have to take the value from this plus 1.9 and plus 0.95. Okay, and for 90 degree, So this value is coming from 90 degree, and our coefficient is coming as 0 and plus 0.6. So you have to fill this 0 and 0.6, 0 and 0.6 for all the column rafter bracing and purlin. Here we have to put. Okay, so if your type is changes, you have to change the section and write your name as L section if you have taken here like this, and here you have to provide your L section for 90 degree we have taken, and the value of 2.0 and plus 1.7. So you have to fill 2.0 here and 1.7 here. Okay, now our C channel will be okay, and value are taken from the table, so this will be okay. This reduction factor value is taken from the table 28. Okay, so you can calculate from this. So we are going step by step, so you can easily understand how the value will be taken for bit calculation. Now these two boxes will be calculation, shown the calculation from 0 degree, that is from x direction, and from 90 degree, that is from z direction. Okay, so our column from 0 degree, our structure size you have to provide here. Okay, so what will be the your width of the structure that is coming in x direction, you have to put here, and what width is coming from the z direction, you have to put here. Okay, so for column, let's see in the design, this will be your design, this will be your column, and we have selected a column. Go and check the 3D, we can also understand from 3D. So our web will be coming in front of x direction, this will be your width, so it is taken as 80 because our size is taken as 90, and our size for columns taken as 90 by 50. Okay, so 90 is our web and 50 will be your flange. Okay, so our width of the section in x direction is 90 degree, and for y direction is 50, but here we have to apply the force from x direction, so we have to take the value for 90 degree. So our force is calculated as 0.1981. so here in calculation from x direction, so you have to apply the force as 0.1981 in global x direction, and we have to close. Again I will show you how we have applied. So we have taken wx lx, and we have to apply, go to member load, and here we have to fill 0.1981 and go to apply for gx and add. Okay, so 1981 will be okay for column from x direction. Similarly for rafter, so what will be the width in x direction, again we will see in similar condition is provided here also. So for x direction, our size of the rafter is 80, so we have taken the size as 80 by 40. So our web size is 80 and flange is 40. So here it is width of the section is 80, force is taken as 0.1761, so it is calculated at, so this value is going to take 0.1761 here. Okay, and similarly for bracing also you have to apply. This column is okay, this will be your rafter, and here we have to also provide for bracing. Okay, so for bracing, so this will be your bracing. On this you have to apply. So for bracing, here we have shown, so 40 by 40 we have taken the size for bracing, 50. So you can also change the name for your understanding here. Okay, so 50 by 40 we have taken the value 50 by 40. Okay, so our x direction value will come as the width is same for the x direction, as our size is main web size is shown in x only, and the width will be 50. So bracing value will come as, forces will come as 0.110. here 0.11 we have taken, and you have to apply these loads, all the loads on the column. So first we have calculated for column, select all the columns, select this, assign to selected beam, assign. Similarly go to select second one and select all the rafters like this. Okay, assign to selected and assign, and similarly for bracing, select the bracing, assign to selected and assign. So it will apply it like this only. Okay, on the structure elements. Similarly for Z direction you can also do. So for column we have done the same thing for the column from Z. So for 90 degree, so this value taken from for 90-degree value we have given here. Here you have to just provide the width of the section. Okay, so this blue box you have to carefully fulfill the values. Okay, don't take the wrong size. So here for column, as we know, 90 by 50, so 90 by 50, so Z direction will be 50. So our value for Z direction you have to take as for 90 it is already coming as 0.00, but if any chance for any section it is coming, so you do not need to consider that value from X direction, just directly consider your Z value. Okay, as we are providing in Z direction only. So our value will come as 0.0322. Applied the pressure, so it is applied. Okay, applied like this. Okay, so it is going opposite to the Z direction, so that's why it is applied in minus. Okay, similarly for rafter also, you can ignore for rafter this. Okay, because if wind is applied from this direction, if you see the figure, so it will easily cut uh, from this. The width of the thickness of the section is 2 mm, so it is so in small that your wind will not affect the structure or the rafter from this side. Okay, so it will directly cut from this and you can ignore the load. And if you want to apply, just apply it, just check the value from this. So see here, your value is so small that you do not need to apply the load. Okay, for rafter at the thickness or width is coming as 2 mm. Okay, so for column we have provided. Okay, and this will be provided for our bracing. So you can provide for the bracing on the bottom in similar way. Okay, this will be your bracing value. So we have taken the bracing for 4 values. That in our another project there were different bracings provided from both the sides. Here it is one, we have to take the value from this. If you provide more bracing, you can insert this value here and you can get the value. Okay, so our bracing is 40 by 50, so our force will coming as 0.026. Here we applied 0.0258, so that is also correct, and we have applied the force on bracing. Okay, this will be our, so you can check the value again for column, and for purlin we have to take the value 0.058. Okay, 0.058. Okay, so here is something wrong because we have provided these values for by mistake for column only. So you have to provide this for rafter. Just select the purlin and select both the purlins and just I to selected beam and applied. So this will be applied on the purling from Z direction. Okay, So we have applied all the loads from all the direction, the downward load, upward load, the loads on the structure elements from our Excel sheet. Okay, so you can easily calculate all the wind load or dead load for solar panel from this Excel sheet. So I will provide the link of this Excel sheet. You can also download it. So this will be your protected sheet. So here you can't change any value in the calculated formula. If you want to download the unprotected sheets where you can also change the formula, or you can fix your box according to your requirement or change the value according to your requirement, so you can also download it. Okay, but here only the value that is shown in the blue boxes you have to change. Okay, so here this will be okay. We have provided all the loads and we have given all the checks. Now we can go for design. So you have to take two codes, that is IS 801 for cold form steel and 802 and IS 800 for general steel. So we have provided these sag rods in between these panels. If you see the drawing here, so I also provide the link of the drawing also, you can download it. So this will be a sag rod. Okay, so which can help you to just connect the purlins. Okay, so this will be taken as general steel rod and it is designed as per IS 800. Okay, so you have taken for both the values and you have to provide the parameters. Select define parameter and you have to give the main information design parameter, that is FYLD of our steel. So here we are going to consider 250, so it is written in kilonewton per meter square. So you have to provide as 250 000. Okay, so as 250 is in newton per mm square. Okay, like this 250.23, add it and close it. Okay, and you can go for command also, go for take the takeoff, take the select and take the check code. Okay, here we have also done these values IS8 and FILD. So for all the select FILD and assign to view, so you can assign for all the structure. Okay, so you can also unselect these sag rods in these conditions. Why? Because it is not cold form steel. Okay, it is taken from general steel which is designed as per IS 800. Okay, selected and assigned to view, sorry, assigned to selected view and assign. Okay, this will be okay, and go to parameter again, IS 801, it is okay. Steel takeoff will be taken and assigned to view and assign. Design check code parameter will be okay here, parameter. So code Indian again 250. So this Sagar will design as per IS 800 from here, and select these, select all those sag rods and assign to selected beam and assign. Okay, check the parameter again and again code Indian, this will be okay. Steel takeoff, this will be okay. Okay, go to analyze, so this will be, we can also check our result from here, as we have taken the takeoff also, steel design also. So here it is shown, and we can also check either every section is passing or not. Okay, like this, and your beam unity check, failed members. Okay. Some member is still failing. Okay, you can increase the size of these members if you want. our purlin is failing. Okay, so we can increase the size of our purlin in design. Okay, go to modeling, check all the other structure elements, still design. The column will be okay, column will be also okay for this. You can also select your field member from here, all field beams, all. Okay, so if you see here, this first beam is okay, the purling will be okay, and this second is, so it is here, it is showing you okay, not design take off. Okay, we can now go to post processing, reactions, sorry, beam unity check, field members. Okay, load is applied, so you can change the section if you want. Okay, but you can also check the sag rod also, check the beam here. So all structure will be okay. Here your purling will showing you not okay. So unity check is coming, and also you can also apply the load combinations from here. You can also define the load combination, or you can go for automatic load combinations if you want. Okay, generate, close. Okay, again analyze, or you can manually give your load combination if you want. Let's check again. This will be okay. Again, go select by specification, all frame page. Okay, this purling will showing you not safe, so it is failing. So you can increase the size of the purling if you want. Okay, go to property, purling 9040 by channel width lift. So here 90, okay, 9040. So it is 9040. Let's change the size, 9050. Okay, go with 9050. Why I am not changing the 90? That is the way, because if you change this, you can again, you have to again change the load. Okay, but I am not going to change the wind load right now. That's why I am taking in 9040, 9050. Here you have to change if you are changing the width of your section from that direction. Change those. Okay, again analyze and analyze. Let's see if number is okay or not. So you can change your size according to your, or if it is structure was failing, you can just decrease the column distance also if you want. Okay, by specification or fail, still it is failing, you have to again increase the size. So once you increase the width also, so load will coming will be decreased. Okay, the forces that is calculated will be decreased. So this will be a purlin, and if you just increase the 100. Okay, so you can also do that if you want. So now I hope you will understand how we design the solar structure. And if you haven't seen this, we have also provided the supports from here. So this will be your support. Okay, all the support will be provided, and we have done the structure here, and just change the purlin size as the load taken was not going to survive the purling, so you have to increase the size of the purling here. Okay, still the design will be same, only you have to increase the size. The purling was not causing, so all the structure remains safe here except purling, so increase the size of the purling. Okay, check the sag rod is also okay right now. Okay, purling is also showing in design, but for unity to check it was not going to pass, that's why you have to increase the size. So I hope you will like this video. If you like this video, please subscribe to my channel, and I will also provide these Excel sheets and our STAAD file and AutoCAD file. If you want to download, I will provide the link in the description also, and also give this in our Telegram group. Okay, so if you like this video, please subscribe to my channel. Thank you.